Good day. So today we will be talking about the decay rate of the nuclear reaction. So this is the part 2 of the nuclear chemistry topic. No? So the decay rate, it is important to know the nuclear decay rate in order to describe the reaction. So this decay rate in layman's term was actually tells you how fast the reaction was. No? So kung gaano kabilis yung reaction. So in a normal reaction kasi, so meron kang parent tapos nagta-transform yun into daughter nuclide. So kung gaano kabilis nako-consume yung mga parent nuclides natin, transforming into the production of the daughter nuclide. So kung gaano kabilis yung reaction, that is pretty much the meaning that we need. So nuclides tend to decay in a given set of time. So this rate was dependent on the change in amount. So paano natin makukuha yung kung gaano kabilis yung isang nuclear reaction? So we take the change in amount, which symbolized by delta n or dn, later part ako, and time of the decay, kung gaano kabilis yung reaction nangyari. Okay, so the shorter the time, the faster, the longer the time. So yeah, so tagal. The rate of expression is the negative sign of the delta n divided by delta t. Okay, in this analogy, so we imagine that the base cake was actually the radioactive nuclide, no? So with his, so mapapansin natin yung time natin, pag binalik natin yun sa zero, kapag kung gaano kabilis yung mawala yung base cake, mabawasan. So ganon yung rate of the reaction natin. So papansin natin habang tinatraverse siya yung time set natin, babawasan siya. So that's how the reaction rate means. So this decay rate was actually was expressed in terms of differential form. So ang tawag dito is the differential form. So the dn over dt is directly proportional to the initial concentration here. So this term pertains to the rate of the reaction. So negative siya kasi ang rate natin ay magiging negative since tinitingnan nating reference dito is yung parent nuclide natin. So since yung parent nuclide ay nauubos o nababawasan, so we need to put negative sign. So medyo arbitrary yung sign placement. So in order for us to express this equation into equality, we actually introduces a term k, which is the rate constant. So yung rate constant na yun is unique per type of parent nuclide. Paano natin siya nakuha? So we isolate dn and n here. So divide both sides by no, giving us this type of equation. So yung dt, hiwalay natin dun sa kanan. So giving us dn over no k dt. So ito yung kailangan nating equation. So that's negative dn over no equals k dt. Yung negative sign lilipat natin sa kabila. So we need to multiply both sides by negative 1. So nangyayari is dn over no negative k dt. Integrating this equation with respect in terms of time. So we have here the time from time 2 to time 1, giving us ln n minus ln no is equal to negative kd here. Then ililipat natin to into the right side, giving us this equation. So itatranspose lang natin yung ln and no dun sa right side of the equation. Magiging positive siya, and then the final equation is this. Okay, so pinapakita ko sa inyo to kung paano natin nakuha yung equation na ln n is equal to negative kt plus ln n. You don't need to memorize this derivation kasi this is just a mathematical evidence kung bakit tayo nag-come up with this type of equation. So let's review this equation. So alamin natin kung ano yung mga terms na present dito. So we have here the n. Yung n natin represents the final amount. The NO represents the initial amount. The K. Yung K natin is yung rate constant. So again, yung rate constant natin is unique per type of nuclide. For example, you have thorium. Yung thorium natin ay may ibang K na value. Uranium, meron siyang ibang K value kumpara dun sa thorium. Tapos yung I, basta any type of nuclide. So, iba yung kanyang K. And the time, so yung time is also the dependent variable here, no? So, kailangan alam din natin yung time. So, let's try to answer the example 1. So, determine the decay constant for carbon 14 if a starting amount of 25 mg decayed into 10 mg after 7574 years. So, paano natin sasagutan to? First, we need to write all the given data or details, no? So, binigyan tayo dito ng 25 mg. So, ano yun? It says that it is the starting amount. So, the starting amount is the NO, di ba? According to formula natin kanina. So, it is 25 mg. So, nag-decay daw yun into 10 mg. So, we can pretty much say that that is the final amount, no? So, 10 mg. So, after 7574 years, so 7574 years, that's the time of the reaction. So, the duration, 7574 years. Then, solve for K, or the rate constant, because yun ang hinahanap sa atin ng carbon 14. Okay? So, how can we solve for K? So, let's write the equation down. So, given yung A naught, given yung T, given yung A naught, given yung T, given yung A, so we can solve for K. We just want to rewrite the equation nga lang, no? So, i-rewrite natin yung equation na nakahiwala yung K. So, paano natin siya i-rewrite yung equation? So, yung terms natin, o yung term natin na kailangan i-isolate is yung K. Nandun siya sa term na KT, negative KT. So ilipat natin yung mga terms sa kabila na hindi naman natin kailangan. So, LNA minus LNA naught is equal to negative KT. So, kailangan lang natin yung K. So, we can divide both sides by negative T para mag-cancel din natin yung negative sign, and then yung T, lilipat natin siya sa left side. So, matitira is yung K here. So, LNA naught minus LNA T. Okay, so paano nangyari yun? Parang nabaliktad yata, sir. Negative sign here was actually redistributed in this one. So, yung LNA magiging negative, at yung LNA, which is a negative na, negative times negative, magiging positive, kaya LNA minus LNA naught minus LNA over T. This is the final equation. So, let's solve for T. So, ln 25 minus ln 10. The time is 74 years. So, let's try to put down. So, ln 25 minus ln 10 divided by 74. So, that is 1.21 times 10 raised to negative 4. The unit for this is milligram per year. Kasi we're given milligrams and the time unit is in years. So, this is the answer. So, kung meron tayong mga problems with regards to involve yung carbon 14, we can use the K for carbon 14 na yung value na to. Next. So, scientists determine the amount of radioactive carbon in an organism remains to know how old the object was. Suppose that 71% of the carbon 14 was detected or were detected. How old is the object? So, this is a kind of hard problem, no? So, medyo advanced siya dahil binigyan lang tayo ng percentage na natira. So, Kapag we are concerned with the percentage, so percentage na natira, so meaning with respect doon sa initial amount ng carbon 14, so ang gagawin natin is i-express natin yung percentage in terms of ratio. Okay? So, this ratio, that actually explains the percentage, no? So, we have here the final amount on the numerator, tapos initial amount on the denominator. So, ayun. No? So, that is the percentage. So, paano natin yun i-express? So, kailangan lilitaw sa equation natin yung ganong ratio. So, ang original equation natin is ln A equal KT plus ln A naught, diba? So, itong term na to, and then ito, kailangan mapagsama natin in form of a ratio. So, paano natin gagawin yun? Hindi natin siya i-divide, i-minus natin siya, and I'll explain why kung bakit. So, ln A, lipat natin yung ln A naught sa kaliwa. So, ln A naught is equal to negative KT. So, that is the equation. So, ito ang concern natin. Ano natin yung gagawing ratio? So, kung mapapansin natin, yung term na ln A and ln A naught, meron silang similarity. So, similarity nila, they both in natural logarithm form or ln. Isa sa mga properties ng natural logarithm ay kapag meron kayong two terms, natural logarithmic terms, that is in subtraction, so we can actually make it in division. Pero kung meron ka namang addition, so we can express that in multiplication. So since this is subtraction, mangyayari is ln A over A naught is equal to negative KT. So ang mangyayari dyan is A over A naught. Okay. Oh, sorry. I used A, but supposedly this A is N. Sorry. Ayan, sorry. Ngayon ba naging A? So, let's do N. So, let's i-convert na lang natin yung mga A into N. Mukha naman siyang ln N naught. So that is ln of 0.71 dahil binigyan tayo ng 71%, diba? So yeah, very inconsistent naman. So K. So anong gagamitin natin K here? So pinag-usapan natin dito is carbon 14. So pretty much we will use the K na nasolve natin kanina, which is the 1.41 times 10. Is it 1.41? Let me check. Oh, it's 1.21. It's 1.21 times 10 raised to negative 4 milligram per year. So, yan. So, solving for the T, or how old the object was. So, that's the T, diba? So, the T is ln of 0.71 divided by negative 1.21 times 10 raised to negative 4. So, let's solve for the ln 0.71 first. So, that is negative 0.342 negative 1.21 times 10 raised to negative 4. So, 0.342 divided by 1.21 times 10 raised to negative 4. So, ang ating time ay 2,826 years. So, 2,286 years yung tanda yung ating object. Okay, so now we will talk about the half-life. So, sa half-life, in layman's term, kapag ang half-life ay narating ng isang bagay, ang tendency is, yung original amount niya ay mangangalahati. For example, meron ka 1 kilong cobalt 60. kapag let's say, ito, maganda example is actually 10 grams pala. Whether we have a 10 grams of cobalt-60, kapag nag-undergo siya ng half-life niya, so, yung isang half-life ng cobalt-60 ay 5.27 years. So, kapag yung isang cobalt-60 ay nakaabot ng 5.27 years, ang tendency is mangangalahati yung kanyang amount. For example, we have 10 grams, so 5.27 years, 5 grams. Another 5.27 years, yung 5 grams mangangalahati into 2.5 grams. So, same with 2.5 grams, pagka another 5.27 years, so 1.25 and so forth and so on. Kung gaano kadami yung cobalt-60, the number of half-lives na undergo nung ating radioactive nuclide. So, the half-life is the time it takes for the nuclide to decay until half of its original amount was present. So, kapag nag-undergo ka ng kapag nakamit ng isang bagay yung kanyang half-life, yung original amount niya is mangangalahati. Yeah. That's the layman's term for that. So, at the T1 half or the half-life, the amount was NO over 2, which or NO or initial amount divided by 2. Okay. So, this is the half-life analogy, no? Kapag ang nangyayari is yan. So, yung cookie ay yung biscuit na nag-undergo. So, ayan, sunod-sunod yung kanyang half-life. Isa pa. So, let's start with it. Yan buo, half-life, kalahati. Half-life, kalahati ulit ng kalahati, and then kalahati nung natira, and then kalahati. Dire-diretso siya. So, half lang ng half ng half ng half. Kung ilan yung mode ng reaction, so, ayan. That is the half-life. So, yung half-life was actually derived from the original equation, the first law equation here. Okay. So, ipapasok natin yung ating expression na yung N is equal to NO over 2 here. And then, this is our half-life. So, ang mangyayari dyan, kapag inilagay natin yung term dito, so, magiging magkasama sila. So, that is ln NO, shortcutting ko na para mabilis. NO over 2 NO. Dahil ang mangyayari dyan is ln NO over 2 minus ln NO dahil magbago sign ng term na to. And then, applying the properties of natural logarithm, so magiging parang division sila. So, we can cancel this and then equals negative k t1 half. So, magiging ln 2 siya. So, kapag naging I forgot. So, we need also to multiply. Before that pala, we need to multiply it by negative muna to eliminate this. So, sige pa. Pa-show ko na nga sa inyo. So, let's restart here. So, ilipat natin din yung term. So, we got ln NO over 2 minus ln NO is equal to negative KT 1 half, multiplying both sides by negative 1 dahil we don't need the negative sign here. So, mababago yung sign. So, magiging ln NO minus ln NO over 2 is equal to KT 1 half. Okay, so applying the properties of natural logarithm here. So, we have here NO over 1. Bakit over 1? Because NO is a whole number, no? And then, divide natin siya ng fraction. So, NO over 2. So, we can cancel the NO. And then, by FOIL method, i-multiply natin yung nasa baba doon sa extremes. So, kung naalala nyo yung means and extremes, KT 1 half. So, mangyayari is ln2 is equal to KT 1 half dividing both sides by K because we want to isolate the T1 half. So, ang matitira is this formula. So, let's do sample problems. Example number 1. So, the half-life of protactinium-234 is 6.68. So, sulat na natin agad. So, T1 half is equal to 6.69 hours. If a 0.812 milligram sample of PA239 decays for 40 hours, so binigyan tayo dito I think ng initial amount. So initial amount is NO and not 0.812 milligrams. Okay, so nag-decay daw siya for 40.1 hours. So the time here is 40.1 hours. The question is how much of the isotope remains. So kailangan nating alamin yung final amount. So paano natin isosolve yun? So ang gagamitin natin is yung original equation natin, which is yung integrated form plus ln n, it's not a, it's n. Okay, so binigyan tayo dito ng NO and not. Binigyan din tayo dito ng T. We have the T here. So, wala tayong K. Hindi natin alam yung rate constant ng ating sample. But we can actually compute for the K using the T1 half. Remember yung formula na ginamit natin to get the T1 half, which is the T1 half is equal to ln2 over K. Pwede natin i-modify yung equation to get the K using the T1 half actually. So, paano natin gagawin yon? We transpose these two terms here. So, K is equal to ln2 over T1 half. So, ln2 here is 0.693 plus yung T1 half natin is 6.69 hours. So, ano yung ating K? 0.693 divided by 6.69. The answer is 0.1036. Okay, so this is milligram per hour. Next, so meron na tayong value ng K. So this is our K. So rewrite natin yung K dito sa left. 0.1036 milligram per hour. So gagamitin natin ngayon yung K na to solve for the N. No? So to get the N, we use negative K T plus ln n O. So paano natin siya isosolve? So negative K, which is negative 0.1036. Yung time natin is 40.1 plus ln, yung NO natin is 0.812. Paano natin yung isosolve? So solve muna natin ln 0.812. That is negative 0.2008. So multiply din natin yung 40.1 times 0.1036. So that is negative 4.15. Okay, so in here kailangan natin perform the operation. So negative 4.15 minus 0.208. So that is negative 4.358 ln. Kaya nga lang hindi pa tapos yung ating problem. So we need to get the actual value of n. So paano natin gagawin yun? Kailangan nating kunin yung anti-ln no ating term. So if you have a calculator, a scientific calculator just like this, you can actually press the shift key and then press the ln here. So kapag nakita nyo na yung shift ln, mapapansin nyo meron kayong function na e. Okay, so yun yung anti-ln functions natin. So in order for you to get the anti-ln function, so this left side magiging n lang siya, and then magiging e raised to negative 4.358. The answer is 0.0128. So yaan na lang yung natitira after 40.1 hours. So that's how you solve for the type of problems like this, no? So combination siya nung half-life natin, ng half-life formula yung ln2 over k, tapos yung original formula natin yung integrated form. So dapat magkasama siya. Okay, so for the last one, so this is the last example. A certain radioisotope with an amount of 2.86 grams decays to 0.358 grams over a period of 22.8 minutes. What is the half-life of the radioisotope? So this one is the reverse of the other one kasi, diba? So yung sa last example natin, we use the half-life to get decay. Okay? But in this, we are solving actually for the half-life using K. Okay, so this is the reverse. So, as a certain radioisotope, so binigyan tayo ng initial amount na naman. So NO, 2.86 grams. Tapos nag-decay daw siya, naging 0.358. So that is our final 0.358 grams. Tapos ang time na na-consume natin is 22.8 minutes. What is the half-life of the radioisotope? Okay. To get the half-life, diba? To get the half-life, ang formula natin is ln2 over k. So, since walang k na binigay sa atin in the first place, we need to solve for k. How can we solve for k? We use the original equation, the integrated form, ln n is equal to negative k t plus ln n. Okay, so we need to solve for k given kasi yung a, t, and no. So paano gagawin natin? So ln n is equal to negative kt plus ln no. So gagawin natin is ililipat natin yung no dun sa left, giving you ln n minus ln no is equal to negative k t. So let's solve for the value of k muna. So divide both sides by t and then multiply both sides by negative 1 to get rid of the negative value. So magiging negative yung kaliwa. So giving you k is equal to ln no minus ln n over t. So ln n o ln 2.86 minus ln 0.358 time is 22.8. I-rewrite natin dito. So ln 2.86, that is 1.05 minus that is negative 1.03. 22.8. So 1.05 minus negative 1.03, so that magiging positive yun. So eventually Ang sagot is 2.08 divided by 22.8. The answer is 0.091. So the answer here, the K value is 0.91 grams per minute. So ito yung rate ng ating equation. Pero hindi pa tayo tapos. Ang hinahanap sa atin is yung half-life. So paano natin isosolve yung half-life using the K? So T1 half is equal to ln 2 over K. So ln 2 is 0.693. Yung K natin is 0.091. So ilan ang ating half-life? By 0.091. The answer is 7.62 minutes. So yan ang ating half-life. So after 7.62 minutes, mangangalahati yung isotope natin, yung amount niya. So that's all for this lecture video. So I hope you learned something dito sa ating video. If you want, you can actually watch other videos that also teaches nuclear chemistry. For this one, I think gagawa pa ako ng isang video to show you how to solve more problems involving nuclear chemistry. So hanggang dito lang yung ating lecture. So I hope nalaman nyo yung mga mga techniques natin necessary to answer problems regarding the nuclear reaction. So yun lang. Stay safe and God bless.